Any questions from the last session?
No.
So let me share my screen. Yeah. Okay. Could you see my presentation right now?
Yes.
Okay, great. Let's start. During the last session, we were talking about the OSI model, especially about this first three layer, physical data link and network. And among them, mostly we need this physical, and more we need this data link layer, because we need to know more details about this wireless frames. So, and frames is the name of data with headers and footers in data link layer, second layer. And then we were talking about Wireshark, and we've seen how we can capture the packets. Today, now we are going to talk about a bit wireless details and some abbreviation, especially we have to know about them, as we see, like BSS, DS, ESS, because during this course we are using this, and even while we will going to, for example, AirMon or AirPickup or all of these tools, we will face with such abbreviation. So that's why we have to know what does each of these abbreviation means. And for you also is important to know each of these abbreviation stands for what. So today, firstly, we are going to talk about two wireless operation mode, and later a bit forward, we are going to talk about one operation mode, which is not officially operation mode. Oh, sorry, not here. Which called monitor mode, and then going deeply into the packet of, into the frame of wireless, and we will talk about this. And if we got some time, we are going and again with Wireshark trying to exactly watch this structure deeply, and hopefully since the next session everything goes more attractive. So there are two main wireless operating mode. We call them infrastructure mode and ad hoc mode. In bus mode, there is a service set identifier, as we know that it's known for us as SSID, the name of this wireless, which we search always and we connect, we call it SSID. And it stands for Service Set Identifier, is required for network verification. Like when we want to verify in any wireless network, we need this SSID. Later we will see that, but this SSID can be even hidden. So sometimes you search the wireless network, you cannot find the name among the wireless SSIDs which you can see, but you can connect to that wireless because you can hide this SSID. This is part of the verification, so that's why it's possible. And actually, we will practice this together, how to hide the wireless name like SSID. Actually, this is part of the security, like one of the very first step to protect your wireless is to make it hidden, at least. Totally, we will see how it's possible even to find it out find this name, but in total, this is one very first step which you can use. In infrastructure mode, we have an access point. Of course, all of you have this access point, which mostly act as a wireless router also, because you have a WAN and also maybe you have a few LAN ports and you have a wireless network. So because there is different network and you can route between all of those, we call it mostly as a wireless router. But imagine that your wireless doesn't have none of those functions. This device itself, it can be access point, and other computer devices will connect to this access point. Yeah, so that's why it's connected. It's called access point because this is a point for access from all other points. While in ad hoc mode, there is a station that creates a network set. Like my computer make a network set, and your computer or your phone will connect to my computer. That's it. That's why it's called peer-to-peer sometimes. Yeah. Later we will talk about it more deeply. Now let's start from infrastructure and go about infrastructure. Infrastructure mode actually should like that. Ad hoc mode and infrastructure like this. In infrastructure mode, there is at least one access point because we can have many access points there. And one station. So I have one access point and one station to connect to this access point, which together form a basic service set called BSS. I've said this. One moment. Here. There is an access point, at least one station. So this combination, or we can have more even a station, or we can have more access point also. So this combination as a minimum, one access point, one station, is called basic service set, BSS, okay? Access points, most commonly they are connected with a wire together, like here as you see. If two access points, they connected with a backbone, doesn't matter. Imagine with the wires together, we call it a distribution system or DS. So if you are talking about a DS, it means that two access points. Of course, if we have an access point, structure mode. So if two access points, they are connected with a backbone together, this backbone can be a wireless backbone again between these two also. Later we will see it called WDS, or with a wire system, doesn't matter. So anyway, there is a DS, distribution system here. Any question till now?
No.
Okay. Another word, another terminology is ESS. An extended service set is a set of two or more wireless access points which connected at the same time with the same wire together, and they are connecting to a single logical network segment together, and all of these devices all together, it's called an ESS. So as here we can see in this picture, we have access point, we have a station. So this access point, they are connected together with a distribution system because these two access points are connected together. One of these access points with the stations is called a BSS, basic service set. another access point with a station, another BSS. And now, because we connected them with a distribution system, with a DS system here, so in total, all of these packages is ESS, extended service set. So just these two access point and this backbone, it's called DS. Just one access point and a station or a stations, it's called BSS. And when we have this together, all it called ESS. Everything clear?
I think yes.
Okay, great. So later on, just when we are going to use Linux mostly for practices, the infrastructure mode, which we have access point, Linux call it as master mode, and the station, when we have ad hoc mode, actually, Linux call it mostly as managed network. So if you see the managed, just remember this is ad hoc. When there we've seen the master, just remember this is this infrastructure, which is access point, act and play there. So let's go for ad hoc mode right now. Last slide, again, let me come here. Last slide, we had an access point and the stations was connecting to the access point. But right now, we have just a stations, and a station, wirelessly, they are connected together. That's why we call it ad hoc mode. Ad hoc mode, sometimes in some book they call it independent basic service set, IBSS. So here you had BSS, basic service set, but here you have independent basic service set. Why independent? Because there is no access point like here. And just a station, each stations, they are independent, independently work. So an independent basic service set consists of at least two stations and communicates without any access point. That's why, because we have two stations, that's why it's called sometimes peer-to-peer. So different name we have for ad hoc mode. We have like IBSS, we have peer-to-peer, we have ad hoc. So all of them, they means just one, like one station, one station. In ad hoc mode, each of these participants, like each of these stations, they take some responsibility. They can have beaconing and authentication for new client who join the network, okay? These two rule. So these two rule also is important for us. So each of this station can have one of these two rules. We can have a wireless distributed system. WDS is very similar to DS. Just in DS, they were connected by a cable. In WDS, this W stands for wireless. So we have everything exactly like DS, just wirelessly they are connected together. So imagine in this picture, these access points were connected by a cable, so it was DSS. Now they are wirelessly connected to each other, so they are WDS, wirelessly. But when you are connecting two access points with a cable together, you have just one connection. But when you are connecting two access points wirelessly together, you can have two different options here. Wireless bridging, or repeating. So that's why in some access point, especially this new access point, you can find these two options. You want to use WDS or not, turn on, turn off, and then ask you that you want to use bridge or repeating. If you use the bridging, there is communication just between access points, not between stations. So if these two be connected in bridge mode, just these two access points communicate between each other, just access points. It can be mostly for management. It will be used for management, wireless management. But these stations, they cannot, because this is connected to this access point, this connected maybe to this access point, according to this fig. So these two cannot be connected. But if you use wireless repeating, so this station which connected to access point 1 can communicate through this access point to a station here. So that's why it's called repeating, because it's extend also your wireless range as well. So you can extend your wireless range with the help of WDS. Like, for example, you are going to some hotels or airports or somewhere like that. You move between floors, or from this part of the airport you are going to another part, but still your phone is connected to the same access point maybe. It's because they used wireless repeating, and the access point repeat and extend the wireless network. So it doesn't matter you are connected in which of these access points. Anyway, the stations can connect together. So that's called WDS. Any question?
No.
Great. So two main modes we understand right now, infrastructure and ad hoc. We have another mode, monitor mode. Monitor mode. Monitor mode is not really a wireless mode. It's something which in books mostly you cannot see this as wireless mode and types. So it's especially important for attackers, because when you want to start some attack, you need to analyze, and in addition to your analysis, you need to manipulate something in wireless packet. So as Linux is open source, and or the tools which can manipulate the driver of the wireless network adapters, they take advantage of this monitoring mode. One of the reasons last time I suggested to have such kind of wireless network adapter, it's because they have packet injection. So in addition that you can manipulate the wireless frames, you can inject the packet because of such kind of wireless network adapter. In a nutshell, these words which are written here is exactly a good definition for monitor mode. Monitor mode allows a wireless card to monitor the packet that are received without any filtering. Monitor mode is essentially the promiscuous mode equivalent for wireless. So if definition, because that's not something in books possible to find it very good, because this is something in, for example, if you download some book how to use Kali, I don't know, or something like that, or hacker student, something like this, you can find definition for monitor mode. But if you are going for course of CWNA, CWNP, the course of wireless networks, those course doesn't have definition for monitoring mode because they don't need it. They are not attack. When you are using some wireless drivers, this mode allows for sending a raw 82.11 frames. That's why we can manipulate and inject anything we want inside. And the tools which we are going to use later on, like AirDump NG, like AirPlay NG, and many of this, like NetScrambler and other tools which for attacking to wireless networks we are going to use, I can say all of them, they need monitor mode because they need to manipulate or go inside of the wireless frame. So that's why the mode which we really need to work with is this monitor. And just simply with one line command, we can Airmon NG start your wireless network. You can start monitor mode on your wireless network card. So if we got time today, if not, since the next session we are going exactly to use with this monitor mode and see what will happen during all of this. So that's wrong. Oh, that's interesting part. This diagram which you see here, this is wireless Mac frame. Just a moment, let me back here to this OSI here. In this layer 2 of OSI, we have two sub-layers, MAC layer, media access control, and LLC, link control, logical link control. They are two sub-layer of layer 2. Here, we see, we can see MAC frame. So again, frame and MAC frame. So everything shows that we are in layer 2 exactly. Which is standard? Standard 82.11, which is actually wireless standard. We have a header, as usual, data, and frame check sequence. 3 bytes, 30 bytes header contains these parts: frame control, duration, addresses, sequence control. And frame control, again, it contains, one moment, just a moment. It contains 2 bytes, like 2 multiplied by 8, like 16 bit. And this 16 bit divided like, if it's a bit make you confused, so we are going to talk about each of these parts. Protocol version. Protocol version is just 2-bit, so it can be 0 or it can be 1. By default is 0. So I will show you a table here. A bit further, we will talk about this table and the details of these tables. But totally just now, I want to describe how this packet looks like. Okay, we have a type, which this type has a lot of subtype, which I've showed you. This is just the subtype of this packets, which is possible. And this type and subtype determine the function of the frame. So because each frame, which in wireless we send and receive, it has some function. Is it for authentication? Is it for different kind of, this is acknowledgement, this is the authentication packet, a lot of different functions. So in total, we have three different frame type field. They are control, data, or management. If again I'm going there, you can see there are some management, there are some control, and we have some data. And data, it has many information inside. So if the type number be 1, this is control. If the type number be 2, this is data. And if the type number be 0, which in the beginning, mostly we face this part, this is management. Sending SSID and most of these things, so we can see all of this. There is DS, to DS, or from DS. These two fields, which each of them, there is just 1 bit. So they can be 1 or 0. And this indicates whether this frame going to some access point or it came from some access point and another distribution system. We say that this DS stands for distribution system. So depends on here be 1 or 0. We know that it came from somewhere or it goes to somewhere. More frag, it's actually full sentence is more fragmentation. I indicate whether there is more fragmentation of the frame of following this one or not. So what is the fragmentation? When you slice the packet, so it's called fragmentation. So because we cannot send the big packet always, so we make fragmentation. So for example, if I have a box like this, and I have to send all of that, I make a fragmentation. I detach it, I send it once, and in another, I will send this one also, yeah? So each of these, they have some numbers to identify, and later in destination, somebody will take them and say, so this is 1, this is 2, and I should attach them like that together. So in network mode also we have the same things. We have fragmentation, and if after this frame which I'm sending, there is another part, there is another fragment and frame. So here this more fragmentation is 1. But if this is the last one, of course, the more frag is 0 because this is the last one. We have another field called retry. Again, this is 1 bit, means that just 1 or 0. And that indicates a frame being transmitted or not. So it's about that the frame which we are talking has been transmitted or not. The next is power management. Power management indicates whether the sending station is in active mode or in power saving mode. So if we are in active mode, power management is 0 because we don't have management on power. If we are in power saving mode, power management is 1 because we have power management. That's why we are in power saving mode. So we save this. Mostly in phone or something, you can see when your phone sending some beacons or some frames. Sometimes you can see this power management. WEP, when you want to join to some wireless network, mostly you write some password, and this password, it's an authentication key for you. This authentication key called WEP, it doesn't mean that if it's WEP exactly we are using a web. Maybe you are using WPA, WPA2, even WPA2, I don't know, PSCAR or Enterprise, it doesn't matter. Any of this authentication mode you use, this field itself, it's called WEP. And this one indicates for do you have authentication or not. So that's why there is just 1 bit for that. So if you have authentication, this WEP is 1. And if you have open network, which you don't have authentication, like this free Wi-Fi is without password you can connect, so this field is 0 for that. And the last one, which called order, again 1 bit, which means again 1 or 0 it can be, and indicate if the frame being sent using strictly order service class. And this field mostly is not set, just because in destination you always have the order of the frame, so mostly this field is not set. Like you can see there is nothing in it. I know these theories sometimes can be bored, but make you bored. But this boring theories, later you will see we need all of them actually. Really, we need them. So for me, they are so attractive because I've used them and I'm using them. So I know later on what will happen. So for me, they are so attractive. That's why I know when it's 1, when it's 0. But for you, maybe right now be a bit strange, but I advise you to keep all of this information in your mind and keep all of them, save all of them by your heart, because you need them exactly later when you analyze wireless packets. You exactly need to know, I don't know, what is this WEP, what is this type of protocol, what is the subtype of them. So they are really, they are important. Any question?
Honestly, not everything is clear, but later I'll read it.
Okay, okay.
And I wanted to ask, I was in Egypt and I was connected to reception Wi-Fi and was chatting with my friend in Vkontakte. And someone connected from my account, and it was like me and the other someone were chatting with my friend. So it can be, as you said in first lesson, you were taught about like my device is unlinked, for example, to Wi-Fi, and then it linking, and by that way it could happen.
Okay, look,
it's just interesting for me. I wanted to ask how it.
Yeah, sure. I will describe it for you right now. Look, it doesn't matter that you are using infrastructure or ad hoc mode, and it doesn't matter that you are using like BSS or ESS. So even while you are connected at your home, like you have one access point, and your phone or your computer can be as a station, and you're connecting to this access point. Another station can be connected. For example, your computer is here and this is your phone, and by your computer you can start some attack on your phone, because anyway you are in the same network. So this kind of attack, one moment, if I can open something to show you, one moment. Yep. The kind of attack which you face with, it's kind of man-in-the-middle attack, which means that if I have some good photo of it, one moment. Yeah, I can describe it better. Something like that. The client wanted to connect to some server, but somebody stay in the middle and capture the packet. In addition to this, they started cookie hijacking or cookie stealing, cookie hijacking, and they stole your. You said you were using WK. So they stole your cookie which you had for your vContacte, and inside of your cookie there is a session number. So while you are connected, if I use the same session number as you use, the session is alive still on the server. So I can be connected with your cookie. So without having your password, actually, I can be connected as you. So actually, this is mix of one attack for taking the network firstly, man in the middle, and then when take the network, so sniff your packets and sniff your information among your packet, exactly target for like a cookie, take your cookie and reuse it on my own computer. All of this, yes, unfortunately, is possible. And to attack to the network, we will see how we can attack to the network later. During this course, we will see, at least in wireless. So just remind me a bit later again, and we can, because that's not some kind of hard attack, so easily we can simulate it. Like I can simulate it, for example, at home with my phone and computer, and I can show you how this kind of attack going on. And even while you are writing your password, especially if that's not HTTPS, like without SSL, if you are using some HTTP website, definitely clear text, they can even see your password, because everything's transmitted through somebody else. So you are not connected directly, you are connected indirectly. Later in our protection part, we were talking about these things, that while you are somewhere in public network, like hotels, I don't know, McDonald's, I don't know, this restaurant, airports, or all of this place, better to not use some of your sensitive accounts, because or the company, for example, the McDonald's or the airport itself, or somewhere which created that network for you, or somebody like an attacker. Imagine you are sitting at an airport and I am there also. So just by curiosity, I want to see what people are doing here. So I can see these things. It's possible to capture the network information in this way. Now, while we are using Wireshark, we just see our computer packets. Yeah, but it's possible to see other computers' packet who are in the same network with us. In wireless, a bit easier. In cable network, the same. but no, in wireless it's a bit easier because everything is wave, so it's easier to capture all of those waves. So that's it. Easily, if I want to give you a clue for that, let me show you something. Look, that's my ARP table here. Okay, here it shows that this is the IP address of my access point, which actually is my gateway, and that's the MAC address of my access point. Okay, so we know that in layer 2, here, we don't have any IP address, and the access point works in layer 2. They are not router, even if they have function as routing. So the access point part, the wireless part, works in layer 2. The routing part is another function which between these networks they route. Or a switch, for example, a normal switch, your access point also can have function as switch, because most of them they have 2 or 4 ports which you can connect by cable to them. The switch itself also works in layer 2. Let's come back here to search for it. So switches works layer 2. So that's why these kind of devices, they have no understanding about this IP. They check everything by MAC address. Okay, so that's why in your own computer also you have a table which called ARP table to point IP address to each MAC address, because when you want to make a packet is in layer 3. Before packet, you need the MAC address. So you put the IP address, but some devices, they have no understanding about this IP, and they check just till layer 2. They even don't open another layers. So they can see just this layer 2 address. Now an attacker tries ARP poisoning or ARP spoofing attack. What is ARP spoofing attack? My name is Mahyar, okay? So I am sitting here and I can say, my name is Maxim, my name is Maxim, my name is Maxim, my name is Maxim, my name is Maxim. So suddenly in your mind will appear that my name is Maxim. And if somebody recently and newly joined to this network because they don't know what's my real name, they say, oh no, he's telling that my name is Maxim, so he's Maxim. Yeah. So in this way, it's possible to poison the ARP table. So suddenly, if I start such kind of attack, you can see we will have 2 IP addresses, but with the same MAC address. Not just in my computer, because if I do it in my own computer, it's called MAC cloning. So it's different. But I advertise my fake MAC address, my fake IP, my fake MAC address with my own IP address for whole the network. So in other computers, phone, and all devices, they can see my IP address with the same MAC address as the gateway has. And when they want to make a packet, they put my IP address for that MAC address. And when it goes to the router thinking that, okay, because I am a router, I'm not layer 2 device, I'm layer 3 device. So I check the IP address. Check the IP address, this is my IP address. And router will see, okay, I have to route it to someone, and now this someone connected to my switch or wireless network. And wireless network or this switch, they are in layer 2. So I need to put the MAC address for them. So put the MAC address, which is the wrong. And the packet comes to me. So indirectly, all packets comes through me, and I resend them again to the real router. because I made this a kind of attack, so I rewrote the packet. So I'm sitting in the middle, and all the packet comes to me. I captured everything, and I can open the packet and read all of that. That's why I say this part is very interesting for me, because even later on, when you want to have understanding about some protocol, how some protocol works, for example, you can say DHCP RFC, for example. Internet Engineering Task Force, we open DHCP RFC. Since yesterday, my internet lag. So actually this updated by those, let's open this one, for example. It's one of them which contains the packet structure. Oh, that's the packet structure. That's the packet structures. In different situations, you can see different packet structure and each of these parts doing what exactly. And if you want to make some attack to this protocol, you need to have understanding about this. So as you know this packet structure better and more, you can obtain more information from each part of this packets or frames. It depends on in which layers they are going. Yeah. So now because we are studying about wireless, where is it? Here. We are studying about wireless. That's why we are going to have better understanding about the wireless, because firstly we try to attack to wireless networks. So later you will see how much these very simple fields, which each of them there is 1 or 2 bit, they can be very useful for you to make attack to wireless networks. So the attack which you faced in Egypt, it was kind of man-in-the-middle attack. It's not part of our course, but easily we can simulate it in one of our sessions. And just remind me later again. And no, that's it. That's it.
Okay, thank you.
Pleasure. Let's come back to presentation. Yeah. So we've been in header. In header, we've been in frame control. And inside the header control, we've seen there is a lot of bit, and we understand each of these bit doing exactly what. Now let's continue. No, wait. Here. We have to talk about this duration. After frame control, we have duration or duration ID. Depends on the frame type. The frame type here. Oh, just a second. Something happened with my computer. Just a second. Just a second. Yep, sure. Depends on the frame type which we have. This duration or duration ID can have different meaning. They can have a power save pool type 1, or with the subtype of if the type is 1 and the subtype is where's my mouse? If the type is 1 and the subtype is 10, so it's power save. It means the station associate ID. This is like one of the station association ID, or it can be any other type and subtype. So this is just exception. Type 1, subtype 10. And for the rest, the duration value can be used for network allocation vector. It's called NAV. Network allocation vector. That's not important. That's why I haven't even write it down. So after duration, we have field of addresses. Different addresses can be here. So if we check this table, depends on this part, to DS and from DS. We have, because there is 2 1-bit, so in total we have 2-bit, and for 2-bit we have 4 different possible combination. Yeah, because each bit is 0 and 1, so 2 in the power of 2, 4 different combination we have. If 2DS is 0 and from DS is also 0, it means that we are in IBSS mode. What was IBSS mode? It was ad hoc mode. Oops.
Independent basic service set.
Yeah, exactly. It was ad hoc mode. Yeah. So if you have these two fields 0 here, so we are in ad hoc mode. And in this case, we have we have just 2 stations, and these 2 stations communicate between each other. So the first address is this address, the second address is source address, and the third address is BSSID address, which is kind of like the access point address. In this case, it's who generate this network. So if my computer generate the network and act like access point, and my phone connected to my computer, the BSSID address is my computer because my computer created that. So it depends on my phone sending message to my computer or my computer sending message to my phone. The source and destination could be different. Yeah. So in this way, they communicate between each other. If 2DS is 0 and from DS is 1, so it means that an access point talking to an station. So we have an access point and a station. So 2DS is 0. So this packet is not coming from somewhere, it's from DS. So from a DS, it means that an access point start to talk with an station. So again, you see the destination address, the second address is BSSID, and the third address is the source address, like this, like in this way. Vice versa, if 2DS is 1 and from DS is 0, it's exactly vice versa of this situation. So if here access point was talking to a station, now here a station will talk to access point. So the BSSID in the beginning, then source address, then destination address. We can see. And if both of them, they are 1, source 2DS and from DS it's 1, so it means we have an WDS network, a wireless DS network, and these 2 access points, they are talking to each other. Now in this way everything goes. Any question?
No.
Okay. So then let's come back again to this, because Here we have a sequence control. Sequence control has two subfields as well. A sequence number and a fragment number. A sequence number is 12-bit and a fragment number is 4-bit. Total 16, which is like 2 byte there. Sequencing or fragmentation, that's why here we have a fragment number. Sequencing, like taking a part of a big packet, or fragmentation, again, the same meaning, just different name actually. A sequence number indicates the sequence number of each frame which you send, and one frame can have different fragments. So for one frame, the sequence number is unique and the same, but this fragment number can be changed. The range of sequence number is between 0 to 4095. Totally, there is 4096 option. 2 with the power of 11. And if we passed 4095, the next one again is 0. So after 4095, we have again the 0. It means that, okay, the next frame is coming again. And again, the frame 1, 2, 3, again till 4095, and again, back and forth come back to 0. But the fragment number, which we can see here, indicates the number of each fragment inside each frame which we send. And the numbers is between 0 to 15. So in total, we have 16 different options, 0 to 15. Then we have data field. A data field can contain about 2,324 bytes of data. Here also mentioned, between 0 to 2,324 bytes of data. Just take care of this units, because somewhere here is byte, somewhere here is bit. So data is by byte. This 2,324 is the maximum 8211 max service data unit, like maybe you heard like maximum transmission unit, MTU, of a packet. So in wireless, we have something in wireless frame. We have something it called MSDU, MAC Service Data Unit, MSDU. And totally MSDU is 2,304. But what is this 20 here? So this 20 is in addition. This is because of different encryption. So if we have WEP, in WEP we have, maybe let me write it somewhere, one moment. This information can be useful for you. We have WEP. In WEP we have 8 bytes of data. This is 2,304 plus 8. It can be 2,312, yeah? Bytes. If we use TKIP, TKIP is WPA1. This is one. Okay. It has 16, sorry, 16 is WPA2. It has 20 bytes. So its data field, which is 2304 plus 20. So that's the maximum which we can reach, 2324. And if we use CCMP, which is WPA2 actually, here we have 16 bytes. So 2304 plus 16 will be 2320. And they are bytes. Yeah. So let's put data field in 8211 frame. So this maximum calculate in this way. We have, let me write this one also here because this can be useful for you. MAC service data unit is MSDU is always equivalent to 2304. So this 2304 came from here. This is the MAC service data unit, the maximum of. MAC service data unit is equivalent to 2304. Any question?
No questions.
Okay. And we have here a frame check sequence. I think you're familiar with that. The frame check sequence is a cyclic redundancy check, or CRC actually, of a current wireless frame which we send. So if I want to send an envelope for you, I will lock it somehow and put a stamp here. I don't have nothing to use as a stamp. Well, let's say like this. That's a stamp here. And when I send you, I say that I put a signature like that. I put a signature here. When you receive the packet or the frame, it doesn't matter in which layer we are talking, because in different layers we have this frame check sequence or CRC. Check here. I've written here and where is it? I've written here an M. If somebody open this packet and again try to repack it, this F is not like it was. There is some difference between my signature, which I've told you before. That's exactly how in network the frame check sequence works. So when you send some packet, there is a formula which both sides, the sender and receiver, based on the protocol which they use, they know how to calculate the frame check sequence. So I can say, for example, this part of the data, this part of the data, and that part of the data, inside this function, there is some result for that. That's my frame check sequence. So any data you put, you have some output. So there is some input, function, output. And this output for each single data is unique actually, because here we have a function, yeah? So sender and receiver, both they know how this function works. And both of them, they are using the same function. So as a sender, I made this packet and I send it. But there is some frame check sequence in the end of that. So imagine this is the data and this is a frame check sequence. Yeah. So when I receive it as a receiver, I take it off. I recalculate the frame check sequence myself. I am the endpoint, I'm the destination. I recalculate it again and I will double check with this number which I had. If these two numbers which I calculate and it was in the packet, they've been the same, so the packet was exactly what we needed and exactly what the sender sent for me. But if these two numbers be different, it means that the packet it was manipulated or it has some error inside or something happened to this packet. So, and depends on the protocol which we use. Maybe I drop the packet, maybe I try to repair the packet, maybe I ask the sender to resend it for me. It depends on the protocol because each protocol works in some way. Yeah. So if you see here, for example, there is retry here. You can see the retry. So it's because if there is some error, so maybe they resend the packet. Yeah. So if, for example, uh, there is possibility to, in some protocol is possible, depends on till how many bits, based on the function which they have, till how many bits they can have error recovery. They do error recovery, so they find the error, so 1 or 2 bit or for example 4 bit during the transmission what was corrupted, so they can recover those uh, bits, and without asking for resend the packet, they can regenerate the packet themselves. So this frame check sequence is exactly uh, used for that, to understand that the packet which we received is exactly what the sender sent to us. It's not manipulated. There is no error. The data is exactly what we expect. Again, another reason which we need to use monitor mode, one of the very important, is exactly this frame check sequence, because if we change the packets, inject something or manipulate inside any frames, actually the frame check sequence also shall be changed. So this application which we use, this I don't know, the scripts or tools which we are going to use, they are recalculating a new frame check sequence based on the data which we manipulated or injected inside the frame. And with new frame check sequence, they will send it. Because if they don't recalculate it, automatically the uh, destination, because of course it can be very huge difference, they will drop the packet. So even they don't check the packet. Yeah. So this frame check sequence is one of the, again, most important. We are not going to deal with it. The tools which we are going to use, automatically they are recalculating this frame check sequence. Okay. And what else we have? Okay, for now, nothing. Just if possible, let me show you a bit. Just a second, let me turn on my colleague. Just while this my virtual machine loading, I will tell you something. I've used this my USB network adapter. So if you are using USB network adapter, you have to come in devices, and from the USB you have to click on it to use this device inside your virtual machine. I think my webcam is connected to this my virtual machine. Let it load a bit. So, can you hear me?
Yes.
My microphone? Yeah, okay. Because I think my webcam now is connected to this virtual machine. No, it doesn't matter. But no, I just wanted to be sure that you can hear. So I've config. I've config. So as you can find here, I have wireless LAN, WLAN 0. So let me show you something. The network. The network which I breached even to my internal, my laptop wireless adapter, inside your virtual machine, that's not wireless. That's kind of Ethernet network. Okay, so that's why we need wireless adapter like USB, like external adapter, or it's because I'm using virtual machine. If I just boot my computer with, I don't know, USB or dual boot with some other operating system, so directly my wireless internal wireless adapter can work for me. But if you have the same situation as I do, uh, you need some wireless adapter. So let's say airmon-ng start WLAN 0. Now I have WLAN 0 mon. In this way, I started monitor mode. So if you want to start monitor mode, you say airmon, monitoring mode, start the name of your wireless adapter. Later, we will use it a lot, and just I want to show some part of this frame. With the sniffing and then wire shock. So here I have my WLAN monitoring mode, so I can start to capture. I want to do something in addition to, as you see, I have a TP-Link access point here. But in addition, I want to use my phone as a hotspot while you're using your phone as hotspot is kind of infrastructure mode. So let me turn it on. Hello?
Hello.
Okay, because I was disconnected, sorry. Okay, so and here, somewhere this Xiaomi, my phone shall be here, oh, here. And this is my phone, started to make some access point here. So let's check one of these packets. Just
We don't see your screen.
okay, just a moment. And now?
Yes, it's loading. Okay.
So that's one of the, for example, frames which are available here. 82.11b on channel 10 working. Everything you can see here. The frame beacon, you can find all of the, like the destination, the receiver, the transmission address, the MAC address of my access point, the source address, BSS ID. So now you know all of this terminology. And the fragment number, the sequence number, you see it's exactly what, where's my PowerPoint? Here, the fragment ID, the sequence ID, the sequence number, yeah? So frame check sequence, and you see it calculated, and the packet which you receive, they say, no, okay, it's correctly here, everything is correct. So let me find another kind of frames. Here you can see the duration, 352 microseconds, for example. That's the type and subtype which we've seen in the presentation. And this is the list which later on we will talk about these things. Some is beacon. Let's find it here again. Where is it? See, this is subtype of acknowledgement. Okay, so this is subtype of acknowledgement. Acknowledgement. Oh, here. So that's a control packet. Yeah. So, but if we check, this is request to send. In this PowerPoint, RTS. Okay, here, yeah, here I have RTS. That's this kind of packet. Again, a control. Yeah. So I'm looking for a beacon. If I this request to send, clear to send. Later on, we will talk about these things because we have to know all of them. I'm looking for a beacon. Let me one moment check the hexadecimal of this. 08, yeah. Wireless LAN main type subtype is equivalent to hexadecimal is 08, yeah. Oh yes, this is big. So here I have some beacon, this kind. And inside the beacon, you can find my SSID also here, the wireless network which I'm connected right now. And RNS, like the noise, and like I'm using TKIP for authentication. As you see, AES, like every single information which you need, you can find here. See, like all of this detail which we were talking about, you can find here. And that's my this wireless adapter information. So my own information, access point information. If here I was talking with some other devices, some other devices information. So you can find everything, and here you can make a filter. Later we will find interesting filters to find good packet, and of course with the help of some tools like uh, later on we will go we are going to use such kind of tools next session, or maybe after one session. I think the next session we are going to start this. Uh, as you can see here, I can see the networks, how many beacons I captured, the power, the BSS ID, actually the MAC address of those networks, and the client which are connected to those networks. You know, for example, there is BSS ID. Now I know, for example, these two devices are connected to this access point. Or for example, these two devices are connected to this C8, this one. And here you can see the encryption which they use, WPA2, WPA2 CCNP. Here they use like just WPA. So in this way, we are going to analyze the wireless, the channels, everything, and then we try to start some kind of simple attack to them, and we are going to understand how we can be protected against all of those attacks. So I think for today is enough. Just please read carefully this, no, except this last slide which I haven't talked about it. So maybe in 1 hour, 2 hours, I will upload this PowerPoint in this Google Class again, like last time. Please just read it, and if you have any question in group, you can ask me, or you can start to talk exactly or make comments on that Google Class also. Actually, try to be a bit active on that Google Class. Later on, I will put some tasks also, because it's possible to have some tasks. I will put some tasks and try to answer the task there, because there I can put marks for you for the session, for each session. So based on your activity on that Google Classroom, I can have evidence to say you had some things during the semester, actually, during this course. And last time I checked, let me check right now again. Just three, Valentin, Max, and Maxime. Just three of you responded to invitation, but three more people are invited, but they haven't opened the invitation, or they haven't accepted the invitation. Please tell to your friend to accept the invitation and join the class. I will upload something in classwork later. Of course, I will put some announcements for you to understand. If I add some quiz or question or assignment, please do it. So check this Google Class, and any assignment or any question, please check. And of course, the material which I upload there, right now there is just one material, like first session. Today I will upload this PowerPoint as the second session material for you. I will add some more here information, because I was talking about some part, maybe like last time. I have to write something for you here to be more understandable. Or if I found some book to have all at once, which we need, I will upload for you. But right now you have just one course material. The rest of the things which I uploaded on Google for you, like this Wireshark cookbook which I upload there, or Instance Wireshark starter, they are not course material, but if you know and if you read them, of course, you have better and more powerful skills to go forward together. So if there is any question, I'm here.
No.
So have a nice day.
Thank you.
Goodbye.
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 Goodbye.